So we're going to start with kind of an introduction to human embryology. That's kind of the study of fetal development, just in case you guys are curious about that. We're going to watch this video. This video is kind of showing us what happens the moment after the sperm and cell have formed into one cell and becoming that first cell that becomes us. Why is it significant? Because at this point, the cell now has two copies of chromosomes, one from the mother, one from the father, so it's considered diploid. And you need a diploid cell really to do this kind of mitosis that we're talking about. While you're watching this video, though, I want you to be taking notes and keep in mind what you just learned about stem cells. Paying attention to things like differentiation, cell growth, etc. The big difference from the video we watched last time on cell growing. Trying to find one that kind of showed a prettier picture.
So look at the beginning of development, looking into the ovary at an unfertilized egg. If that gets fertilized by sperm, which travel down the fallopian tube, so here are millions of sperm coming along. Several of them will hit the egg and try to penetrate it, but one will win, as it were, go into the nucleus, and then there's a reprogramming process where the male and female nuclei have their genes set aside to be turned on and off for early development. Here you see early cleavage stages occurring, and this is one of the early growth phases. As the embryo moves down the fallopian tube, it's going to form an important stage called the blastocyst here in a few seconds. Of course, in real life, that takes days, about 5 days. At this stage, then, I'd like to draw your attention to the inside of the blastocyst, where there are cells called the inner cell mass, which I'll be abbreviating as ICM. Those are the cells that make the entire animal.
So inside the blastocyst, these are your stem cells. These are the cells that are going to become you in the future. Become your skin, your brain, whatever. All these things on the outside become your placenta, or what the embryo develops at. Is it about this?
Yeah. I just wanted to say that that proves that all cells start with stem cells.
Yeah. That's a good point. Nice.
The outer cells give rise to the placenta and other supporting tissue. At this stage, the embryo implants into the wall of the uterus. This is when a pregnancy is really initiated. And now we'll see those blue inner cell mass cells form a disc, and then as the cells continue to grow, they change their physical positions, their kind of geographical relationship to one another. And you'll see that represented.
So at this point, this is kind of our differentiation concept becoming a thing. The reason it organizes into a disc, can someone give me a guess as to why it organized itself in that way? What do you think is going to come out of that disc, that direction? It's now shaped with a front and a back, right? So this area might become the head. This area becomes your rear end.
Sure, this disc gets transformed into an embryo. Those lines represent sites where cells are migrating in and out. And here's an important stage when the three beginning layers of the embryo, the so-called germ layers, are formed.
And so this is the first time you see cell differentiation, right here. So this is and the reason this is important, so for example, the ectoderm ends up becoming your skin, neurons, other important stuff. The mesoderm ends up becoming, like for example, your kidneys, liver, a lot of important organs. That becomes your skeleton muscle. The endoderm becomes like the kidneys and liver. So basically, ecto I kind of think of as outside, meso, middle, your skeletal muscle, etc. Endoderm, things that are really kind of inside your gut, stomach, etc. Pancreas. But
Okay, I'll come back to that in a few minutes.
just right there, you're seeing cell differentiation. And then
As development proceeds, there's more growth and movement of cells, It'll begin to form a neural tube. Here it turns and appendages
Is
start
this
to
your
spread
spinal
out.
cord?
We see the head forming in the eye, and then eventually we get a small embryo, and some months later, of course, this would be born as a young baby.
So, that's pretty explanatory. Kind of exactly how does a single cell organism become a multicellular organism? I kind of really addresses that question directly. But now I want to take a few seconds, a few minutes, to kind of do a review session. So,
I have a question. Like, is it true? Like, when you get a girl pregnant, y'all both get sick?
no.
I don't get sick?
No. You both get sick? No. So it's actually a thing about genetics, or evolutionary kind of, is that women have a lot more death, basically, when they get pregnant. They have to spend a lot more energy and resources taking care of the baby if they get sick. Usually for men, it's not a very long process. Pregnancy doesn't have to do much of it, which is why it's crazy that all these men are the ones who are doing abortion bills, because they have about 10 million investments in the process. Whereas women have a much longer time. So I kind of want you guys to open up your folders and take up notes from the previous few days. Main notes, I kind of covered the vocabulary on topics such as prokaryotes, eukaryotes,